Hello again, welcome to another lesson in Algebra 1. Today we are covering section 9.8, factoring polynomials completely. Alright, so for your warm-up, your first question was to solve. That means we need to find out what values of x make this equation be true. Alright, so our first step would be to set it equal to 0 because we have a quadratic expression. Okay, so then we can factor this into two things that multiply to 0 so we can split it. Alright. So our puzzle in this case is negative 42 and 11. So two things that multiply to negative 42 and 11 are 14 and negative 3. So we make our box. And we have 2x squared, negative 21. We have 14x and minus 3x. So in our top two, 2x is the same. That leaves behind x and 7. And then negative 3 times 7 will make negative 21. And negative 3 times x will make negative 3x. So this will factor into 2x minus 3. X plus 7 equals 0. And then we split this into two problems. So 2x minus 3 equals 0, or x plus 7 equals 0. So 2x is going to be 3, or x is going to be 3 halves. And over here we had x is negative 7. So 3 halves or negative 7. Okay, and number 2, it says factor. So we have 4x squared plus 10x plus 4. So we're trying to find out, split this into 2 or 3 factors, some things that multiply to the top one. And if you look at this problem, you can see that 2 can be factored out, so the greatest monomial factor. So we'll take that out first to make the problem a bit easier to factor the rest of it. Okay, we'll be doing that a lot today. So 2x squared plus 5x plus 2. Okay, if you forget to take the 2 out at first, one of your factors at the end is divisible by 2. So look at your answers and say, oh, I could have divided 2 out of one of those. So this will leave 4 up top and 5. And then two things that multiply to 4 and add to 5 are 4 and 1. So I'll make my box. We have 2x squared in the top corner. We have 2 in the bottom right. And then 4x and 1x. So this is going to be 2x comes out, leaving behind x and 2. And then a 1 comes out, leaving behind a 1x and 2. So 1 times 5, 1 times x makes x, and 1 times 2 makes 2. So this is going to factor into 2, and 2x plus 1, and x plus 2. All right, so what I was saying before, if you factored it without dividing the 2 out ahead of time, factoring out that 2, you're going to either have 4x plus 2 in here, or you're going to have 2x plus 4 in that spot. And and that one can have a 2 factor out of it, and they can just pull it out now. Okay. All right, number 3. A replacement piece of sod for a lawn has an area of 112 square inches. The width is W and the length is 2W minus 2. What are the dimensions of the sod? Okay. So a piece of sod always comes in a big rectangle. So the width is W and 2W minus 2. And we know the total area is 112. So if I multiply the length and the width together, I should get 112. So I'll go ahead and multiply this in, 2w squared minus 2w, and then move the 112 over. That's equal to 0. If I look right now, everything is divisible by 2, so I'm going to divide all the parts by 2. I don't have to worry about factoring it out because here's equation. I can divide every part of the equation by 2. So 112 divided by 2, it makes 56, and 0 divided by 2 is still 0. Okay. All right, so all I have to do is solve the puzzle. So in this case, two things that multiply to negative 56 and add to negative 1. That's going to be negative 8 and positive 7. So that's going to turn into W minus 8. No box this time because we have a leading coefficient of 1. And W plus 7 equals 0. All right. So we solve these separately. W minus 8 is 0, so W could be 8. Or W plus 7 is 0, so W could be negative 7. It doesn't make any sense to have a width that's negative. So our width here is 8. And the length, is, let's see, 2 times 8 is 16, and 16 minus 2 makes 14. So the width is 8 and the length is 14. All right, down below, factor out a common binomial. So if you look at each expression here, okay, we have a binomial that's the same in both. So if you look at here, here's one and here's our other expression. And inside of those expressions, we have x plus 4 and x plus 4. That's the common binomial. So if I factor out x plus 4, that means undistribute it from those two terms. What's left behind is 2x minus 3. So I take out the x plus 4, and you can see what's left. It's 2x minus 3. All right, number 3 we're going to do first. It's very similar. So in this case, I have x minus 3 as the common factor in these two expressions. This expression here and this expression there. So I'll factor out x minus 3, undistribute it, and it leaves behind 4x plus 5. Now, we left number 2 and number 4 for a reason, and that's because the binomials aren't exactly the same here. One's y minus 2, and the other is 2 minus y. So what I have to do is rewrite the other one. So I want this to be y minus 2 also. So I changed both signs. Okay, I changed the negative y to positive y, and I changed the 2 to negative 2. And the way that I did that was I just times it by negative 1. But since times it by negative 1 changes the problem, I need to times by another negative 1, which I'll put with a 5 to keep the problem to be the same. So negative 1 times negative 1 makes positive 1. So which doesn't change anything. So I'm timesing the 5 by negative 1, and I'm timesing the binomial by negative 1. So if you flip the binomial around, you also have to flip the sign of the 5. Okay. Now the y minus the 2 is the same in both, and it left behind 3y squared minus 5. All right. Number 4 works very similar. So I want to change my binomial around. So, okay, we can flip it. But that means I multiplied by a negative. So to keep the problem to be the same, I also will multiply the 3 by a negative. So it becomes plus 3 instead of minus 3. Okay. Now the y minus 5 is the same in both. And what's left behind is 2y squared plus 3. All right, let's flip it over. Page 2, factor by grouping. So we may be able to use the distributive property to factor polynomials with 4 terms. We've already done this inside, you've seen this in Khan Academy. So to factor a monomial from pairs of terms and then look for a common binomial factor, this is called factoring by grouping. So if you look at number 5 and you say, oh, let's look at just a pair of them. So we say, what's the same in the first two? Okay, so this is going to be x squared, and it's going to leave behind x plus 3. And then we say, what's the same in the second two? This is going to be positive 5, and it's going to leave behind x plus 3. Okay, so if you look at it and it has 4 terms on our test, chances are you're going to factor it by looking at the first 2 and the second 2, factoring them out, and then trying to find a common factor in both, which in this case is the binomial x plus 3, which is why we practiced factoring out common binomial on the first page. Okay. All right, number 6 works very similar. We say what's the same in the first 2 that could be factored out, and that's going to be y, and it's going to leave behind y plus 1. And then we say what's the same in the second 2 that can be factored out, and there's an x in both of them, and that leaves behind y plus 1. And now we look to see if there's a common binomial that could be factored out. And in this case, there is. That common binomial is y plus 1, and it leaves behind y plus x. All right, number 7. We have x squared plus 2x, or x cubed plus 2x squared plus 8x plus 16. So since there are 4 terms, we're going to try our trick of trying to factor each of the 2 terms separately. So in our first 2 terms, we could factor out an x squared, and it leaves behind x plus 2. In our second 2 terms, we could factor out an 8, and it leaves behind x plus 2. And fortunately, all these problems are set up nice where there's a binomial that's the same in both afterwards. And then what gets left behind in our case is x squared plus 8. All right, number 8, same thing, 4 terms. So we'll look at the first two. There's an r that's the same in both, and it leaves behind r plus 4. And in the second two, there's a t that's the same in both, and it leaves behind r plus 4. So r plus 4 is the common binomial in both of these terms, and r plus t is what is left over after I factor out that common binomial. Okay, on our last page here, we have a little rule up top. Okay, on our last page, we have a little graphic organizer to tell us the steps to factor completely. Step number 1, factor out the greatest common monomial factor. So look for anything that will divide into all the terms, okay, and then undistribute it. Step number 2, look for the difference of two squares pattern or a perfect square trinomial pattern. Remember, you can find those by looking at the first and last term and seeing if they're perfect squares. They're a good tip-off for you, okay? Number 3, factor a trinomial in the form of ax squared plus bx into a product of two binomials. That's our normal factoring that we do. And then step 4, factor a polynomial with 4 terms by grouping them and then repeat steps 1 through 3, okay? All right, so we always want to repeat the steps until we can no longer do any of them. All right, so factor each polynomial completely. So step 1 for this one, there's nothing that divides evenly into all of them, so there's no common monomial factor. Step 2, look, see if it's one of our special ones. The square root of this is n, and the square root of this is 1. N times 1 is 1n, but if we double it, we do get the 2n in here. So this is one of our special ones. So this is going to be n minus 1, square root, and because it's a minus, it goes here, and then we square it. Okay. Number 10, 4x cubed minus 44x squared plus 96x. So step 1 would be look for a common monomial factor, and there is one in this case. It's 4x. It leaves behind x squared minus 11x plus 24. Okay, this helps us a lot because now what's left behind has a leading coefficient of 1, and it meets our third step up here, which was factor anything in the form ax squared plus bx plus c into a product of two binomials. So two numbers that multiply to 24 and add to negative 11 are negative 3 and negative 8. So this part will change into two binomials. The first one is going to be x minus 3, and the second one will be x minus 8. Remember, it has a leading coefficient of 1, so we do not need to do our box here. All right. Number 11, we have a common factor in both of these. So 2h squared can come out. And what got left behind was 25h squared and 1. So whenever it's a binomial and it has h squared in it, you can probably bet it's a difference of squares. So if you look at our first term, the square root of that is 5h. Second term, square root is 1. So this is a difference of squares. They can both be square rooted evenly. So we're going to write this as 2h squared, and then 5h and 1, and 5h and 1. And remember, with our difference of squares pattern, 1 gets a plus and 1 gets a minus. In our last part, we have the directions solve the equation. So these are a little harder because they have all of our steps of factoring involved. So in the first one, we go step 1. There is a common factor. We can take out the w. That leaves behind w squared minus 8w plus 16 equals 0. Step 2 also works on this because this is one of our special ones. Square root of w is w, and the square root of 16 is 4. So 4w times 2 does make the middle of 8w. So this is w, and then w minus 4 squared equals 0. Remember, the minus decides to go here. And then we split this into things to solve. So w could be 0, or w minus 4 could be 0, or w minus 4 could be 0, but we already have one, so we don't need to write the second one. So w could be 4. So our answers here are 0 and 4. All right, last one, number 13. There's a common factor. It's x. It leaves behind x squared minus 25. Okay. Then this x squared minus 25 is a special one too. Whenever it's a binomial with squares on each side, so we know it's the difference of squares. This square root is x. This square root is 5. So remember, we do x and 5. X and 5, one gets a plus and one gets a minus. That's how we do our special difference of squares. Okay, so this is going to split into 3 parts. One answer is going to be 0. The second answer will be -5. And our last answer is going to be +5. Okay, so we get 3 answers, 0, -5, and +5. All right, so our Khan Academy follow-up here is solve quadratic equations by factoring with a leading coefficient of not 1. So this is just review from 9.6. So make sure that you give it a little practice in, because those are the ones that will show up more on the test. Okay. All right, I'll see you in class next time. We'll practice 9.8, and then the test is the time after.